Alright, so in this problem, I have 8 to the power of 11 plus 8 to the power of 11 plus 8 to the power of 11 plus 8 to the power of 11. So I want to find the value of this. So for my solution, I'm going to rewrite my equation, my problem over here. So 8 to the power of 11 plus 8 to the power of 11 plus 8 to the power of 11 plus 8 to the power of 11. Now, notice how all of these terms here are the same. So I have all the same terms adding with each other. And if I have something in the form a to the power of b plus a to the power of b plus a to the power of b plus a to the power of b, I can simply just factor out a to the power of b from here. So I get a to the power of b times, well, a to the power of b divided by itself is 1. So I get a to the power of b times 1 plus 1 plus 1 plus 1. So in this case, I have a to the power of 11 plus itself 4 times. So I can factor out a to the power of 11, and I get a to the power of 11 times 1 plus 1 plus 1 plus 1. And now 1 plus 1 plus 1 plus 1 is equal to 4. So I get a to the power of 11 times 4. Now from here, a to the power of 11, I can rewrite this as 2 to the power of 3. All I did was rewrote 8 as 2 to the power of 3. And now 4, I can also rewrite this as a power of 2. 4 is the same thing as 2 squared. From here, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of 11, that's going to equal 2 to the power of 3 times 11, which is equal to 2 to the power of 33, because 3 times 11 is 33. So I get 2 to the power of 3 to the power of 11, which is equal to 2 to the power of 33. So now I have 2 to the power of 33 times 2 squared. Now the last part is fairly easy step. Because both of these bases are the same, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So over here I have 2 to the power of 33 times 2 squared. I can think of a as 2, m as 33, and n as 2. So I can rewrite this as 2 to the power of 33 plus 2, which is equal to 2 to the power of 35. So this is my final answer, and I actually can't simplify this anymore because 2 to the power of 35 is a crazy big number. So this is my final answer. And also, the only way that this solving process could have been faster is in my first step over here. I took a whole 3 steps to rewrite a to the power of 11 plus itself 4 times as a to the power of 11 times 4, when I could have just saw that when it's the same term adding by itself x amount of times, it's just that term times x. So that's a faster way. Alright, so in this problem, I have x to the power of 9 plus x to the power of 6 is equal to 36. So I want to find the value of x here. Now x to the power of 9, I can rewrite as x to the power of 3 times 3. And x to the power of 6, I can rewrite as x to the power of 3 times 2. So I get x to the power of 3 times 3 plus x to the power of 3 times 2 is equal to 36. Now from here, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 3 times 3, that's equal to x to the power of 3 to the power of 3, and x to the power of 3 times 2, that's equal to x to the power of 3 to the power of 2. And this is equal to 36. Now I'm going to let x to the power of 3 equal to the variable t. So I get t to the power of 3 plus t squared is equal to 36. And now if I subtract 36 on both sides, I get t to the power of 3 plus t squared minus 36 is equal to 0. Now to solve an equation like this, what we have to do is first find one solution and use that solution to find the remaining solutions. And to find that one solution, we just actually have to plug in numbers and see if they work. So I'll first start with t is equal to 1. If t equals 1, I get 1 to the power of 3 plus 1 squared minus 36, which does not equal 0. If t equals 2, I get 2 to the power of 3, which is 8, plus 2 squared, which is 4, minus 36, which again does not equal 0. Now if t equals 3, I get 3 to the power of 3, plus 3 squared, minus 36, which does equal 0. So t equals 3 is a solution to the equation. Now what we can do with t equals 3 is divide t to the power of 3 plus t squared minus 36 over t minus 3. And whatever equation we get from this is what we have to factor out and find the solution to. So how do we divide these two? Well, t to the power of 3 plus t squared minus 36, I can rewrite this as t to the power of 3 minus 3t squared plus 4t squared minus 36. And from here, I can factor out t squared from t to the power of 3 minus 3t squared, and 4 from 4t squared minus 36. So I get t squared times t minus 3 plus 4 times t squared minus 36. And t squared minus 36 is the same thing as t plus 6 times t minus 6. Sorry, this isn't supposed to be 36, this is supposed to be 9. So I get t plus 3 times t minus 3 is equal to 0. Now from this whole thing, I can factor out t minus 3. So I get t minus 3 times t squared plus 4 times t plus 3, which is equal to t minus 3 times t squared plus 4t plus 12. Meaning, t to the power of 3 plus t squared minus 36 divided by t minus 3 is right here, t squared plus 4t plus 12. So now this gives me two equations. I get t minus 3 is equal to 0, and t squared plus 4t plus 12 is equal to 0. So obviously t minus 3, we already know the answer to that is t equals 3. But for t squared plus 4t plus 12 is equal to 0, to solve this we're going to have to use the quadratic formula. So I get negative 4 plus or minus the square root of b squared, so 4 squared, which is 16, minus 4 times a, which is 1, times c, which is 12, all over 2a, so 2 times 1. And this is equal to negative 4 plus or minus the square root of 16 minus 48 over 2, which is equal to negative 4 plus or minus the square root of negative 32 over 2. And this is equal to negative 4 plus or minus the square root of 32 times the square root of negative 1 over 2. And the square root of 32 is the same thing as the square root of 16 times 2, which is the same thing as the square root of 16 times the square root of 2, which is the same thing as 4 root 2. So this is equal to negative 4 plus or minus 4 root 2. And the square root of negative 1 is the same thing as I. And I have this over 2. And now if I divide this by 2, I get negative 2 plus or minus 2 root 2I. So t is equal to negative 2 plus or minus 2 root 2I, as well as 3. Now, we're not done yet, because remember how we let x to the power of 3 equal to t. So I get x to the power of 3 is equal to 3, and x to the power of 3 is equal to this. However, we can't take the power of a number and make it have an imaginary solution, so we cannot use this solution of t. So the only solution we can use is x to the power of 3 equals 3, and if I take the cube root on both sides, I get x is equal to the cube root of 3.